Good morning, fourth grade students. Happy Monday to you. Welcome to another edition of Eureka Math. And Eureka is a Latin phrase, and translated into the English language means I have found it. It's also our state's motto. What have we found? We found the best way to learn math, and that's more valuable than gold itself. Let's start off with our objective today. What is our objective today? It's right here. Solve two-step. That's the key right there. Two-step word problems, including multiplicative comparison. Let's get started with our fluency practice. Remember, two-step word problems. Let's do, what should we start off with? How about 245 times 2? Let's use the partial product to solve this first, okay? 5 times 2. What is 5 times 2? That is 10, right? Now, here's where some of us get mixed up. This is 40 times 2. It's not 4 times 2, it's 40 times 2. So we're dealing with the tens. So I'm going to put in 0 here, and 4 times 2 is 8. We go over here, and how many zeros do we need to place down here? Well, we're multiplying 200 by 2. So in the hundredths realm, I'm putting 2 zeros there, and 2 times 2 is 4. Let's add it up. 0, 9, and 490. Now, for those of you that are fans of the standard algorithm, let's take a look. 245 times 2. Okay, 5 times 2, we know it's 10 from over here. Well, so much for the standard algorithm. 5 times 2 is 10, we put the 1 there. 4 times 2 is 8, but we need to add that 10, so it's 80 plus 10 is 90. And 2 times 2 is 4. 490. Voila! How about that incredible area model? Terrible looking rectangle, Mr. Leggett. So we're going to have 2 times 2 hundredths, 4 tens, and 5 ones. 2 times 2, 4. Right, 2 times 2 is 4. 400 in this case. 2 times 4 is 80. Make the 400 there, I'm so sorry. 80, and then 2 times 5 is 10. Add them up, 400, 80, 90. All right, let's do another one. And this is 301 times 5. And let's do the partial product first. 1 times 5 is 5. 0 times 5, 0. Don't need to add anything to that. Let's just go to 3 times 5. Remember, we're multiplying 300 times 5. 5 times 3 hundredths, 2 zeros, and 15. 5, 0, 5, 1. 1,505. Let's go over to the standard algorithm. 301 times 5. If you're comfortable with this, please do it on your own and then just double check with Mr. Leggett. 1 times 5 is 5. 0 times 5 is 0. 3 times 5 is 15. And there you have it. How about a area model? All right, how about it? So we have 5 times 3 hundredths, 0 tens, and 1 5. 5 times 1 is 5. 5 times 0 is 0. We don't need to put anything. And 5 times 300 would be 15. And put in the 2 zeros for 100. Add them all together. We get 1505. Okay, let's move on over to the concept development. Let's see what's going on here. Looks like a pretty exciting problem. We got this chart right there. And let's get started. Problem 1. This table, we call this the table shows, not shows, the cost of party favors. Party favors are things you give guests to your party. Each part, boy, I made a few typos here last night. Let's correct them. The table shows each party guest receives a bag with one balloon, one lollipop, and one bracelet. What is the total cost for 9 guests? It says do your best. Well, let's underline what we know. Each party guest receives a bag with one balloon, one lollipop, and one bracelet. What is the total cost for 9 guests? Okay, so I'm going to circle 1, 1, 1, and 9. All right, the first thing we have to do is we have to figure out how much one balloon, one lollipop, and one bracelet cost together. So we need to do a little addition. So let's get ready to add. Let's add, and this symbol means cents. So 26 pennies, 14 pennies, 33 pennies, or other combinations. So I'm going to say 26, 14, and 33. Time to add them up. And I'm going to put the cent symbol right there. All right? 6 plus 4, 6, 7, 8, 9, 10 is 10, plus 3, 11, 12, 13. Carry the 1, or bring the 1 over, excuse me. 2 plus 1 is 3, plus another 3, 4, 5, 6, plus 1 would be 7. So each bag costs 73 cents. Now, the second part of this problem is we need to figure out how much, because we're budgeting our party, we need to figure out what's the cost for 9 guests. So as you might have guessed, 73 cents times 9. All right. Let's do the standard algorithm. We can deal with it. I know some of you like the partial product, some of you like the area model, some of you like the place value disk, but let's just go ahead and do this via standard algorithm. 3 times 9, 9, 18, 27. There's my 7 and my little 2. See it, 27, 2 10s, 7 1s. Make sense? 7 times 9, you could use your multiplication chart if you don't know that off the top of your head. 9, 18, 27, 36, 45, 54, and it is 63. Plus the 2, 64, 65. So we have 657 cents. And what we're going to do is take this and we're going to write our statement. The total cost for 9 party guests is 657 cents. That would translate to $6.57 because, of course, there's 100 pennies and a dollar. We're going to move on. Problem 2 about the Turner family. See what those crazy Turners are up to again. The Turner family uses 548 liters of water per day. The Hill family, they don't care. They leave their faucets running. Uses 3 times as much water per day. How much water does the Hill family use per week? Yikes. Okay, got a lot going on here. So let's make a tape diagram with the Turners. And this is going to be your exit ticket today too, this similar problem. So the Turners use $548 liters of water per day. That's how much they use per day. The Hill family, on the other hand, wasteful as they are, those Hills, they use 3 times as much. 1, 2, and 3. So, each one of these stands for 548 liters. So this would be 548 times 3, right? 548, 548, 584, 548 liters. All right, let's use the standard algorithm to figure out how much water the Hill family uses per day. We're not done yet because we need to find out how much water the Hill family uses per week. So let's find out the day first. 548 liters times 3. I'm going to put my big L right there. And let's use the standard algorithm. That's what we should be using by now. 8 times 3, 8, 16, 24. Bring up my 2. 4 times 3 is 12. This is 3 times 40, right? But we add these 2 10s from the 24, 2 10s, 4 1s. So 4 times 3 is 12 plus 2 would be 14. Bring up the 1 there. That's a 100. So because 40 times 3 is 120 plus the 20 was 140. Now we have 5 times 3, or 500 times 3, plus this 100. So that'd be 5 times 3 is 15, or 1500 in this case, plus 1 more would be 1600. So we have 1644 liters. But now we need to find out how much they use per week, okay? How many days are in a week? 7! Yes, if you said 7 like little Jimmy did, you're absolutely correct. So we need to take 1,644 times 7. Okay, you want to take a look at this. For those of you that still a little unclear on the standard algorithm, we could do this as a partial product, right? We can go 4 times 7 would be 28. 40 times 7 would be 280. 600 times 7, what would that be? 600 times 7 would be 42 hundredths. And 1 times 7, or 1,000 times 7 would be 7,000. That's partial product land. Let's just not finish this up. Let's go right to a standard algorithm. And we'll do 1,644 times 7. All right? 4 times 7, that's 28, right? So we're going to put an 8 here and a 2 right there. 4 times 7, we know it's 28. We just did that. We did it over here too, but we need to add this 2. So 4 times 7 is 28, plus this 2 would be 2930. Put my 0 there and my 3 up here. Over here, 6 times 7, we know it's 42. We need to add that 3. In reality, this, of course, is 600 times 7. And then we add the 300. So 6 times 7 is 42, plus 3, 43, 44, 45. Bring up the 4. And 1 times 7, in this case, actually 7 times 1,000 would be 7,000. But look, we have to add this 4,000 onto that 7,000. 7, 8, 9, 10, 11. So if we did everything correctly, this should equal 11,508. 8 plus 0 plus 0 plus 0 is 8. 2 plus 8 is 10. 2 plus 2 plus 1 is 5. And 4 plus 7, 8, 9, 10, 11 would be 11. And there we have it, 11,508. And we could take a look at this as a tape diagram too, but, or an area model, I'm sorry, but we're not going to. We got to get moving. Going on to our next problem, problem number 3. And Jaden has 347 marbles. Elvis has 4 times as many as Jaden. And look, the people here at Eureka have a sense of humor. Presley's the next person's name, Elvis Presley. Presley has 799 fewer than Elvis. How many marbles does Presley have? So here we see, you know, we've been doing this all along. It's all about a 2-step process, okay? So get this all copied down. We're going to scroll up. And I'm going to put Jaden, Elvis, and Presley. So Jaden has 347 marbles, right? We circled the 347. $347 marbles. Elvis has 4 times as many as Jaden. 1, 2, 3, 4. Presley, meanwhile, we don't know how many he has, or she, it could be, but we know it's 799 fewer than Elvis. So what I'm going to do is We know it's much less than Elvis. We don't know exactly, well, we know exactly how much less, but we don't know how many he has, but it's 799 fewer. And what we're trying to figure out, of course, is the question is that we squiggly lined, how many marbles does Presley have? That's what we don't know. That's what we're after. The first thing we need to figure out, though, of course, we know how much Jaden has. We know Elvis has 4 times as many. And we know that Presley has 799 fewer than Elvis. So we need to figure out how much Elvis has. So we're going to do 347 times 1, 2, 3, and 4. 347 times 4. Now we could do this, partial product. We could do a partial product. Oh, did somebody say partial product? Yes, I said partial product, Math Mutt. Why do you ask? I love saying partial product. I know you love saying words that start with the letter P. P is a plosive. Plosive. I like saying that word too. Well, should we do this as a partial product? Yes, Mr. Leggett. Let's do this as a partial product. Some of your students I know like doing the partial product best. Do they like doing the area model? Only one. Which one is that? I said I promised not to tell you. Okay, all right, Math Mutt. Thank you for stopping by. We'll do the partial product, okay? Oh, thank you very much, Mr. Leggett. You're very welcome, Math Mutt. So we're gonna do partial product. 7 times 4, that seems to be popping up a lot, is 28. 40 times 4. 4 times 4 is 16, but we're dealing with tens, so I'm gonna put a 0 there. And then 3 times 4 is 12. We've been coming with that one a lot, but it's 300 times 4, 300. So I need to put 2 zeros there because I'm dealing with the hundreds, 4 times 300s, and put my 12 right here. So now we're ready to add. 8, no, you know what? Should we add? Let's not add yet. Let's do standard algorithm, and then we'll come back and add. For you standard algorithm fans, 347 times 4. 7 times 4 we know is 28. There's my 8. I'm going to put a new pin in here, a little 2. See, this is why I don't like doing that. I should have put it way out here. And then 4 times 4 is 16 plus the 2. So that gives us 18. Cross that out. Because it's 18, I need to put my 1 here. Now 3 times 4 we know is 12. Plus that 1 is 13. So Elvis should have 1,388 marbles. Let's come over here and see 8, 8, 3, and 1. So yes, it looks like we were right on both accounts. Now, let's see how we're going to figure out what Presley here has. Remember, Presley has 799 fewer marbles than Elvis, so it's time to do a little subtraction. We're going to take this 1,388 and subtract 799. See, that'll give us Presley. We know Presley has 799 less than Elvis. Elvis, we now know, has 1,388. So let's come right over here and do some subtraction. I can't take 9 away from 8 ones, so I need to regroup. This will become a 7, and this will become 18. Now 18 minus 9 is 9. Once again, I can't take 9 tens away from 7 tens, so I'm going to have to regroup, and this is going to become a 2, and this will be 17. 17 minus 9 is 8. Looks like we need to regroup here because I can't take 700 away from 200, and I'll make that a 12. 12 minus 7. All right, I can just see the difference between 7 and 12. 8, 9, 10, 11, 12. It's 5. So it would appear that Presley has 589 marbles. And, you know, we could have done some mental math. We could have just made that an 800 and taken 1 away from there, but I'm old school. So we'll say Presley has 589 marbles. Thank goodness Presley hasn't lost all of his marbles. Little joke there, kids. All right, let's go to problem number 4. Woo! It says, write an equation that would allow someone to find the value of R. What the heck are you talking about, Mr. Leggett? Well, this is something kind of new. I don't think we've really encountered this too much this year, or maybe not at all, in multiplication, I know that. But follow along with me. Okay? Think about Presley and his marbles. So we have tape diagram broken up into 3 parts. 1,167, 1,167, 1,167. There we have it. Now, what we're going to do is make another tape diagram that's not quite as large. It's going to stop a little bit there. And we'll do a little bracket here with the number 239. And we need to write an equation that'll show the value of r. That's a variable. We don't know the value of it. So what kind of equation would this be? Well, we know that r would equal this mystery number plus 239 would equal 1,167 times 3. What are you talking about, Mr. Leggett? Well, take a look. We have r, the mystery number, plus 239 is equivalent to 3 times 1,167. We could also do another way. We could say r equals 3 times 1,167 minus 239. So those are 2 ways that we can come up with the answer for r. Should we come up with the answer for r? No, because all we're asking is to show is an equation to find the value of r. You see how this would work? R is this much plus 239 would equal 3 times 1,167. Or r would be this much minus 239. That would equal r. I'm going to move on to our own. Ooh, this is a good one. It says, write your own word problem to correspond to the tape diagram and then solve. Well, I'm going to have to draw the tape diagram for you, so let's do that. This is kind of like the problem we just did. In fact, it's very much like it. In fact, it might be identical, don't you know? And we're going to go 1167 grams, 1167 grams, 1167 grams. So we're going to go below here. Why do they do it like this? And we're going to go dot, 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 239. All right? So let's figure out the solution to this, to find out what and we'll say M for math mutt. So we're going to find out how much math mutt weighs. All right. First thing we're going to do is we got to times this. We got to multiply 1,167 times 3. All right. So we'll say 1,167 grams times 3. All right. I'm going to put my G's down there for grams. Let's use the standard algorithm. 7 times 3. 21. 6 times 3, or 3 times 6 tens would be 180, plus those 2 would make it 180, 190, 200, or 20. You could think about it. 6 times 3 is 18, plus 2 is 20. See the 20 right there? 1 times 3, or 3 times 100, plus 200s. So 1 times 3 is 3, plus those 2 would be a 5, or 500. See how it's in the 500s place? And then finally, 1 times 3 is 3. So we have 3,501. Let's go back and put that this equals 3,501 grams, okay? So let's go ahead and now figure out how much Math Mutt weighs. He weighs 239 grams less than 3,501 grams. And here I'll show you a fancy trick. It's going to blow your mind. Okay, so we're going to minus 239. That space right up there. That's going to be in grams. Huh, how do you do this, Mr. Leggett? What's the fancy little trick you're going to show us? Well, what if I were just to do... it's not that good of a trick on this one. I'm not going to bother with the trick. We're just going to do straight across subtraction. So I can't take 9 ones away from 1 1. I can't take 3 ones away from 0 ones, 3 tens away from 0 tens. So I'm going to go to my 500s right here. That's going to become a 4. My tens will become 10 tens or 100. Then I need to work over here and regroup this. This is going to become 90 and this will be 11. 11 minus 9. Well, 9, 10, 11 is 2. 9 minus 3. 3, 4, 5, 6, 7, 8. What? 3, 4, 5, 6, 7, 8, and 9 is 6. 4 minus 2, 2. And didn't bring down the 3 is 3. So it looks like Math Mutt weighs 3,262 grams. But we need to come up with a word problem that will explain all this. So let's say calculating cat weighs 1,167 grams. We could say Math Mutt weighs, we have the EI saying A, weighs, long A sound, weighs 239 grams less than 3 calculating cats. Calculating cat weighs 1,167 grams. Then we would say, how much does Math Mutt weigh? So we've created a problem for all this. And I'm going to zoom out a little bit and get the whole problem in here. So we can see the 3 calculating cats. They each weigh 1,167 grams. We know that Math Mutt weighs 239 grams less than 3 calculating cats. So what we did is we multiplied 1,167 times 3 to get 3,501. That's the weight of 3 calculating cats. Then we subtracted 239 to get the weight of Math Mutt. Alrighty, we're going to move on with our problem set. And you'll find your problem set today on page 43. And this is 10/28/19 on Monday. I'm actually doing this right before the Big Fall Festival. So we're going to tackle our problem set and then we'll be logging on to Zern. Feel the Zern. Okay, I got it pretty close where I wanted, I think. There we go. Let's do some math. More math. It says solve using the read, write, draw, write process, RDW. We know all about that. So let's read first. We're going to underline what we know. Over the summer, Kate earned $180 each week for 7 weeks. $180 for 7 weeks for each week. Of that money, she spent $375 on a computer and $137 on new clothes. So $375 on a computer and $137 on new clothes. It's going to ask how much money did she have left. All right? So let's figure out what's going on here. Let's start out with seeing how much she made. $180 each week for 7 weeks. So let's do you know what? Boys and girls. Excuse me, I'm going like, this problem's not right. I pulled out the wrong paper. So go ahead and put that one back in your book. and take out lesson 12. Mr. Lee thought he was so prepared, but he was here awfully late last night. In fact, don't take out 12. So sorry, kids. Mr. Lake's just a little confused this morning. We're going to go ahead and do this one right here. Just one problem before we log on to Zoom. So, $180 each week for 7 weeks. Let's do 7 weeks. 1 week, 2 week, 3 week, 4 week, 5 week, 6 and 7. And each week she's pulling in $180. Okay, let's find out how much she made in those 7 weeks. We're going to go 180 times 7. 0 times 7 is 0. 8 times 7, always a tough one, 56. Let's remember 5, 6, 7, 8. 56, I'm going to put my 5 right here. 1 times 7 is 7, plus the 5, 7, 8, 9, 10, 11, 12. Be 1,260. So that's how much money she made. But we got to figure out how much she spent. $375 on the new computer and $137 on new clothes. So I'll put $375 plus $137. 5 plus 7, 7, 8, 9, 10, 11, 12. 7, 8, 9, 10, but plus that 1 would be 11. And bring up the 1. 3 plus 1 plus 1 is 5. So she spent $512. Now what's our next step? Well, I'm going to go ahead and label this because I forgot to do that. 7 weeks. Go ahead and make that label. So I need to subtract this amount from this amount. So we'll say 1,260 minus 512. How are we going to go about this? I can't take 2 ones away from 0 ones, so I'll have to do a little regrouping. That'll become a 5, and this will become a 10. 10 minus 2 is 8. 5 minus 1 is 4. I can't take 5 hundredths away from 2 hundredths, so this will become a 12. This is a 0. 12 minus 5, 5, 6, 7, 8, 9, 10, 11, 12. So it's 1,248. I want you to keep this paper, put it back into your problem set, and we're going to take a look, you lucky dogs. Woof, woof. Not you, Mathmat. I'm talking about the kids, your lucky dogs, because we're going to set up your homework for you today. So, take out your homework book, and that's page 37. And it says use the read, draw, write process to solve the following problems. And the table shows the number of stickers of various types in Chrissy's new sticker book. Chrissy's 6 friends each own the same sticker book. How many stickers do Chrissy and her 6 friends have all together? This is kind of a tricky one because you think about Chrissy and 6 friends. So you have Chrissy plus 6 equals 7. So there's a total of 7 people. We need to add this up. I'm going to put a plus sign there. You're going to need to add that up and then multiply it by 7, okay? Number 2, the small copier makes 437 copies each day. The large copier makes 4 times as many copies each day. How many copies does the large copy make each week? All right, so we have small copier. I'm going to put S for small. It does 437. The large copier makes 4 times as many. 1, 2, 3, 4. What you're going to have to do is 437 times 4. Then you're going to have to multiply that answer by the days of the week, 7 days of the week right there. All right, and then you'll have to say your statement right here. The large copier makes blank copies per week, period. Let's go to number 3. Jared sold 194 Boy Scout chocolate bars. I didn't know they sold chocolate bars. I'm going to circle the 194. Matthew sold 3 times as many as Jared. Okay. And then Gary sold 297 fewer than Matthew. This is kind of like our other problem we just did, right? How many bars did Gary sell? Well, let's set up this problem. We have 194, so Jared is 194. Matthew sold 3 times as many. And then Gary sold $297 fewer than Matthew. So you have to work this problem out. Turn the paper over. Write an equation that would allow someone to find the value of m. All right, well, think about it. We have 723 times 3. So, and then we have this amount right here, 973. So there's a lot going on here, all right? So, what we could say is we need to figure out this, excuse me, looks like it's having brain freeze here. We need to figure out how much this is right here, from here to here. So we would say 700, and, oh, excuse me, we need to figure out the whole thing here, all right? So we would say, just think about it, 723 times blank plus blank equals m. Now, they want you to write your own word problem to correspond to the tape diagram and then solve, all right? So we're looking for m, just 723 times something plus something. I gave you some hints, and we could write a problem. So you try to come up with your own word problem, be creative to figure out what's what here, all right? Thank you so much. That's your homework for the night. And I look forward to seeing you all tomorrow, Tuesday. Bye for now. Do a great job for Mrs. Chandler.